is the ASS of 64500, which consists of its own ASN and its customers, which are 501 and 502. Now to its transit provider, I want to accept any, but except with an exception of I want to filter bogus IP addresses, including the private IP addresses which are not routable. But I want to announce this AS set to my upstream provider 64.5.8.5.10. Now, as I said earlier, RPSL, this is the routing policy specification language that is used to create these route objects within an IRR. It is a rich language that is used to express complex constructs in order to prevent a wide range of scenarios. Now, a third party, such as this one, could take this autonomous system number outnum object, collect its customer con, collect related route and route 6 objects to generate a list of prefixes that represent legitimate announcements from this ASN to its peers by taking advantage of the RPSL language. Now, whether you keep it simple or whether you document every last detail of your configuration depends most on your preference of your organization. MANRS participants with unusual or complicated policy may choose to describe this separately in a human-readable document made available to other operators via a link to the document's location in the remarks attribute of the outnum object. The remarks attribute is used for providing extra information. Now, for this case, it is used to provide a link that is used to provide more clarification of a particular complex RPSL network routing policy. Now let's do this demo. Yes, I am requesting information from the aggregator entity com for this IPv4 prefix. It gave me three route objects, one from RADB, another from the RPKI to IRR conversion process, and another one also from RADB. You can also try your own IPv4 block. I can try one from my ISP, Habari node in Tanzania. Okay, you see here they have a route object in RADB. This route object is for PCCW global customer route, which is being exported under this origin autonomous system. It was only created because no existing route object with the same origin is found. You can see these filters. Okay, you can read this information. So it basically means that you can see here from another route object from RADB. It is a route object for this IPv4. This autonomous system number that belongs to Habari node is allowed to originate this IPv4 prefix. Source from RADB, and it was created by people from MX. I see. Now this is just a route object that is part of the WHOIS server hosted by Afrinic. This is not the route object I am referring to in IRR. This is a route object for the WHOIS system, database system. This one too, it is coming from the WHOIS server. This comes from the WHOIS server of RIPE. Okay, let's go to RPKI. Now, in addition to providing information to Internet Routing Registry systems, you also need to document your network expected announcements, which will be stored within a ROA on an RPKI repository, as I said earlier. We are still on global validation. Now, an RPKI dashboard offers an interface for performing various operations such as creating and publication, modification and deletion of ROAs. Now you can visit your own regional internet registry portal to create these specific ROAs. Now this is an example of a ROA which consists of 4 columns. The first column, autonomous system number. This is self-explanatory. It shows the autonomous system number. The prefix, it shows the prefix is that this autonomous system number is authorized to originate. The most specific prefix, that this autonomous system number is allowed to originate, and the affect is a column that shows the routes that are affected by this particular ROA. Now, these are the explanation of the different columns of that ROA. I've already talked about them. Now, this is a very important point. An issuer of a ROA should advertise all prefixes that are covered by the ROA all the way down to the maximum length, because an attacker can take advantage of this. Now, imagine this autonomous system with autonomous system number 64500 owns a ROA with this particular prefix and a maximum length of /24. Now, this means that if this autonomous system number advertises only one block of this IPv4 prefix and doesn't advertise another, an attacker can take advantage. He can advertise this block and he can append the appropriate ASN, which is 64500, without making other RPK validators to invalidate such an announcement. So people out there, if you have a ROA, make sure you advertise all the prefixes down to the maximum length of your particular ROA. Now, hosted resource certification service. All regional internet registries offer a hosted resource certification service where keys are kept and managed, and all operations are performed on the RIR servers. Now, each RIR is different, but common requirements for obtaining a certificate include, by this certificate we mean the resource certificate. You should have a valid membership with that RIR. That means you should have already requested a particular IPv4 or IPv6 address space or ASN from it, thereby being a membership of that particular RIR. You should have access to the resource management portal, which obviously you have it if you are a member to it. You should have agreed to the terms and conditions of the service. Now, for more information, you should consult your specific RIR. Mine is Afrinic in Africa. If you are in any other content, you should consult that particular RIR portal for creating those particular ROAs. APNIC for Asia Pacific, RN for American, LACNIC for Latin America and the Caribbean, RIPE for European region. Now we are going to the next MANRS action, which is filtering. Now, MANRS participants should perform the following action in order to prevent propagation of incorrect routing information. First, you should have to define a network routing policy and implement a system that ensures correctness of your announcements and announcements from your customers to adjacent networks with prefix and AS path granularity. You should apply due diligence when checking the correctness of your customers' announcement, specifically that the customers legitimately holds the ASN and address space it announces. Now, by due diligence, he means that maybe you should request some sort of official letter from your customer showing that that particular customer is the legitimate holder of that particular internet number resource, whether it's an ASN or an IP block, IPv4, IPv6 block. Now, most importantly, network operators should secure inbound routing and advertisement. That means the ones that are coming from your customers, through the use of prefix level filters. Also, AES path filters might be used to require that the customer's network be explicit about which autonomous system numbers are downstream of that customers. This is for the case whereby a transit provider has multiple customers, and those customers has multiple other customers. It's a chain. So you should require that your customers to be explicit about its downstream customers in order to get AES path granularity. Now, this is another example of prefix hijacking or route leak. Now, Google, with this autonomous system number, is announcing its traffic using this prefix in its eBGP sessions. Now, a customer in this autonomous system number is able to direct traffic to Google, right? Now, you can see that autonomous system number 64502 is an announcement prefix that belongs to Google. Now, if this announcement is propagated to the internet, traffic will be hijacked eventually. The announcement that is made by this causes traffic intended for Google to be hijacked and directed, as you can see, it is directed to this attacker. Now, this is another example for route leak. As I said, route leak incident occurs in multi-homed stub customers, customers that have more than one transit provider. Now, as you can see here, Google is announcing traffic, and this customer is able to access content that is in Google, as shown with these green arrows. Sorry. So, a route leak, it is the propagation of routing announcement beyond their intended scope. Now, it can occur when a customer announces routes that they learn from one transit provider to another transit provider. Now, this customer is, as you can see here, this customer was announcing that it has a path to Google via this autonomous system number. Now, this will cause this autonomous system number, this autonomous system number, to know that its only path to go to Google is to go through its customer, thereby resulting to a route leak. Now, in order to build prefix filters for your customers, you need to know what announcements to expect from them. You could request this information from your customers. However, this method is inefficient and is now outdated. Instead, the recommended approach is to require customers to register information about their routing policies in a public repository. That means that in order for a particular customer to become your client, that customer is required to register the information in a public repository, such as IRR or RPKI. So, before building filters, it is important for you to apply due diligence and check whether the information provided by the customer about their identity and resources is correct. That means either by using the WHOIS database to check if the autonomous system number and IPv4 or IPv6 prefix are consistent with what the customer is saying, always remember that a filter is as good as the information that was used to create it. So if your customer is incorrectly claiming to hold someone else's address space without additional checks, your filters will allow this false information to come through. It is strongly recommended that you check the holdership of the assigned internet number resources, the ASN and the advertised address space. You can do this by checking the WHOIS database or the RIR for the region your customer operates it. Services like this, that is given by RIPE NCC, can help you identify the region and corresponding regional internet registry of your customers. I have it loaded here. We can check my ISP barrier node AS36909. You can see it's located in Tanzania. Therefore, its regional internet registry is Afrinic. You can get a lot of information from here. Its outnum object, as seen from the WHOIS database, not from the routing registry database. It has 27 IPv4 prefixes and 1 IPv6 prefix. It has 4 observed BGP neighbors and all that. So you should require your customers to register their route objects within an IRR and their object within an RPK repository. Now, how do you use IRR to build prefix filters? First, using an IRR to build prefix filters can be done in the following circumstances. First, you should apply specific prefix outbound filtering for the networks. You should apply specific prefix outbound filtering of your network to your peers and your upstream providers. You should also apply specific prefix inbound filtering for the traffic that is coming from your customers and also the traffic that's coming from your peers. You can see above ones are bogus IP addresses of a computer network. You should consider implementing bogon filtering when you're considering peering with your peers. As you can see here, this autonomous system number will need to document its own route object, and it should define its customer con using the AS set object, and it should publish its routing policy within an outnum object. Now, there are tools available that are designed to work with IRR policies. They can automatically build necessary ingress and egress filters by parsing the outnum object that documents AS64500, any autonomous system number routing policy, to collect all the referenced objects and extract prefixes. You can use the following open source software to generate router configuration for filters from the data that has been provided to an IRR. There is IRR toolset, IRPT, and BGPQ3. For this presentation, we will use BGPQ3. Now, BGPQ3 is a simple command line tool that connects to the particular internet routing registry database, builds prefix filters from the collected data. You can use this tool to build prefix filters for IPv4 and IPv6 prefixes. I have already installed this tool. I can show you. You can use the -4 option specifying IPv4 prefix and -L specifying that particular IPv4 prefix. the example, I can't seem to find another example. But you can use this tool by using the following syntax to specify your IPv4 prefixes. If you want to specify IPv6, you should use the -6 switch or option instead. Now, syntax checks. You should perform some simple syntax checks to ensure your prefix filters that they should not be empty, they should be well informed, they should not contain syntax errors. Some routing platforms treat any empty prefix list as an implicit allow any. You don't want that to happen, to allow any a BGP announcement that might be maybe a route leak or a prefix hijacking attempt. They should not refer to impossible addresses and masks, meaning private IP addresses. You should not block anything which is explicitly configured to pass. Now, the basic idea of validating routing announcements with the RAPK is the same as for IRR. A network operator should register the announcements in the form of raw, and they should also subsequently used to either generate filters or validate announcements using more advanced tools such as RAPK to router protocol. Now, you can install your own RAPK validator, and you can just use it to print or to generate the filters, or you can also use it to validate announcements by taking advantage of the RTR protocol, which is the RAPK to router protocol, whereby your router is communicating with the RAPK validator using the RTR protocol in order to validate announcements as sent from the global routing table. Now, RAPK works with the trust anchors that are issued by the regional internet registry. It also works with the resource certificate, which states what address space and autonomous system number has been allocated, and also it works with raw objects that are created by your customers. Now, imagine that autonomous system number 64501 announces this IPv6 prefix. Now, the trust anchor is used to sign the resource certificate, which eventually the resource certificate is used to sign the raw. Now, if another autonomous system number also announces the same IPv6 prefix, then that particular signed raw will render that announcement invalid. It means that it will invalidate that announcement. That is, as long as other network operators take advantage of the RTR protocol by configuring their BGP routers to communicate with their in-house RAPK validator holding the local RAPK repository cache. Now, this is an example of one of the RAPK validator, which is known as RIPE-NCC RAPK validator, developed by the RIPE-NCC RIR. It has an interface that allows you to query the database of rows. You can then check the row against the BGP routing table and export the rows as route or Route6 objects for integration with the tools that can use IRR. Now, instructions on how to install. Now I'm talking about another RAPK validator, which is known as Routinator. Let's see on the instructions on how to install Routinator for network operators. Now, Routinator, it is a RAPK validator that is developed using the programming language known as Rust. So, in order for you to install Routinator, you should first install the package manager of Routinator, which is Cargo. By this command, you should also install rsync protocol. This rsync package. Rsync, it is the protocol that is used by the validator to request information from different IRR servers. rsync, it is a legacy protocol. Right now it is being replaced by RRDP, which stands for RPKI Repository Delta Protocol. I think multiple regional data registries are implementing it. Afrinic started implementing it this year. Last year they were doing some tests. So you can use the following instructions to install Routinator. I have already installed it. I can show you a list of, let's get to that slide, then you'll see. You can run Routinator in one of two possible modes. First, it can print the list of valid route origins, meaning VRP, validated raw payload, or providing that service for routers or other clients to access this list via HTTP or the dedicated protocol, RPKI to router protocol, RTR, the one that I've mentioned earlier. Now, to have Routinator print the list, you should invoke this command. Now I already invoked that command. It takes a lot of time, so I'll just show you the result that I got. It prints a list of all the ROAs in all the RIR, in all the internet routing registries. See, it's a very long list. This is another command. So as you can see, it is listing all the ROAs that are found. Actually, these ROAs are found in my local cache. As you can see the path here. We could also use let's wait for it to finish. I'll use another. Let me show you the list of ROAs that are found in my local cache. Let's go to that. It also downloaded a list of trust anchor locators, TALs. Let me show it to you. For RIPE, LACNIC, ARIN, APNIC, and AFRINIC. For the case of ARIN, I had to run that command once again by accepting the relying patch agreement, as you can see from this instruction over here. I'll show you. Yes. don't know where that information is, but I had to run the command routeinator. I had to initialize it, but I had to accept RPA, relying party agreement. So that was the only way for me to be able to download our interest link allocator into my local machine. So let's go to repository. Let's see what we have here. Let's go to rsync folder directory. Let's see what we have here. Now let's go to my favorite directory for my regional registry. This should be Afrinic. Let's go to rpki.afrinic. Let's list. Let's go to Afrinic folder. Yeah, so this is a list of resource certificates. As you can see here. Let's see. So this is just shows the repositories for different routing registries deployed by different regional internet routing registries. Now I was showing you these commands. You can filter by using autonomous system number, or either by using prefix, or you can validate a combination of autonomous system number and prefix. This is just another way of telling, hey routinator, I want you to tell me if there is a matching VRP for this ASN and prefix combination. I already ran this command, so I just want to show you guys. I think this was over here. Yes, now it can output this information in two ways, JSON or CSV, comma separated values. Now here I just wanted it to output all the VRPs that are matching this autonomous system number. So these are all of them. As you can see, this command took some time to run. That's why I had to run it beforehand. Now these are the rows. As you can see, consists of autonomous system number, prefix, and the maximum length. The trust anchor, it is ripe. Now it consists of all rows for ripe. Let's see how ripe. Now this is only for ripe. Let me see, because this command was specifying this prefix which belongs to this autonomous system number. It is operated in the ripe NCC region. That's why. So now Routinator supports RPKI RTR as specified by this request for comment 8210. So it will act as an RTR server if you start it with a Routinator server command. Now I haven't configured my Routinator to act as an RTR server. Now you can specify the addresses to listen on. By addresses I mean your BGP IPv4 or IPv6 address that you want this Routinator to listen from. If you don't, it will start but not listen on anything. This may seem a bit odd, but this way you can keep your local repository copy up to date for faster use of the Routinator via PS command. So for example, if this was the IP address of my BGP router, and this was the IPv6 address, I would invoke this command in Routinator in the machine that is running Routinator in order for it to keep on listening requests coming from my BGP border router. Now by default the repository will be updated and re-validated every hour as per the recommendation in this RFC, but you can change that using this option, the refresh option. Now for this case, this refresh option, the value of this is defined in terms of seconds. So by this command, that means you want this Routinator server to refresh its local repository after every 15 minutes. Now this is for the case of the router that you want it to communicate with the Routinator. This is for the case of Cisco. You can follow this sequence of commands to configure your router to communicate with your RPKI Routinator blind party software. Now this username and password you must have already created in that particular server that is running Routinator, and you want this communication to happen in SSH encrypted manner. Now other line party software, or you can call them RPK Routinator, include RIPE NCC, RPK Validator, Dragon Research Lab Validating Cache, Octo RPKI, and Fort Validator. Now as you can see from this diagram, this is our validator. It might be Routinator, it might be RPKI, RIPE NCC Validator, it might be Octo Validator, any Dragon Research Lab Validating Cache, whichever. It communicates with the various routing registries by using rsync. Currently it uses RRDP, RPK Repository Delta Protocol, to fetch such information. Now this information is then used by my router to make routing decisions based on the information announcements my router gets from BGP. Now the router communicates with the validator using the RTR protocol, RPKI to router protocol. Now the result of such comparison of the BGP announcements are sent from the global routing table with those are sent with the VRPs are sent from my local cache. I will either render such announcement as invalid or valid or not found. Anti-spoofing. Now MANRS participants should perform the following actions in order to prevent traffic with spoofed source IP address: implementing a system that enables source address validation for at least single home stub customers, networks, their own end users and infrastructure, implementing anti-spoofing filtering to prevent packets with incorrect source IP address from entering and leaving the network. Now, as I said earlier, that IP spoofing can be used by an attacker to perform DDoS, distributed denial of service and reflection amplification attack, whereby the attacker can take advantage of DNS servers and NTP servers, whereby they can be used as amplifiers by sending small queries resulting to much larger responses. Now, to prevent IP spoofing by using anti-spoofing, it is recommended to implement ingress filtering methods, which are access control list and URPF, unicast reverse path forwarding. To prevent traffic with spoofed IP address, you should use these two techniques: access control list and URPF. Now, by using access control lists are used to filter traffic by controlling whether the routed packets are forwarded or blocked at the router's interface. Here, thereby allowing a specific range of IP addresses and denying all others. They are commonly deployed at the provider edge/customer edge boundary. Now, if a service provider customer location is in this range, now if it receives traffic coming from a range outside of this, for instance, this ISP, it has these two customers. Now it provides this block of IP address to its customers. Now it's receiving traffic that's coming from a different IPv4 block. Then by implementing access control list, it should deny such traffic. Therefore, ACLs should be deployed on the downstream interfaces to the ISP in order to verify the source address used by its customers. Now, this is different commands that are used to implement access control list in different vendors: MicroTik, Cisco, and Juniper. Now, you can also use URPF, unicast reverse path forwarding, which takes advantage of the forward information base table that documents the source IP address that is going into a particular interface. For instance, for this case, it has documented this block coming from interface 1 and this block coming from interface 0. Now, there are 4 modes of URPF: loose mode, strict mode, feasible mode, and VRIF mode. Now, for single home sub customer, it is recommended that you operate URPF in strict mode. Now, for multi-home customers, you should operate in feasible mode instead. Now, for this case, forward information base does not correspond to the incoming interface for the IPv4 traffic coming to this specific interface, thereby resulting into denying this traffic. Now, this is also another implementation of URPF using these major vendors. Now, one way to verify your anti-spoofing is by telling your customers to run anti-spoofing IP spoofing software, which is developed by Kaida. I already ran this. I installed it on my Linux machine and I ran it, but I was supposed to configure my host machine with a public IP address so that I can be able to run this effectively, because it appends your host machine with different public IP address in the same range of your configured public IP address to see if your ISP is able to prevent traffic with spoofed source IP address. So I can show you. So here it is, spoofer. I ran this spoofer prober and it ran for a couple of minutes and it gave me a result. It gave me a link where I went and saw my results. here. If you go through this result, it is because I was running this software in a machine that is having a private IP instead of a public IP. Now we're going to our last MANRS action, which is coordination. Now, MANRS participants should perform the following action in order to facilitate global communication between network operators by maintaining globally accessible and up-to-date contact information. Now, you should maintain your contact information either in a WHOIS database for your specific regional internet registry, or IRR database, or PeeringDB, or your website. Now, while all of the regional internet registry require their registrants to keep their primary contact information up to date, the IRR also offer capability to add additional information to records in the databases. Now, Afrinic, APNIC, and RIPE have their own WHOIS system that combine Internet Number Resource Registration with IRR, which means that the additional objects you should create, including maintainer object, role, initnum, and initnum6. These are objects that are mainly found in WHOIS database. Now, the maintainer object, it is an object that is used to manage authentication and authorization in order to protect the other objects from being manipulated by unauthorized people. The role object is an object that references important point of contact, and it can be identified by its NIC handle attribute. Initnum and initnum6, as the name suffice, they just only show IPv4, IPv6 address blocks. Now, this is an example of a role object. As you can see, we are taking advantage of the remarks attribute to provide more contact information as part of our coordination action. As you can see also in the initnum object, we are using the remarks attribute to provide contact information. Now, we can also use internet routing registries to provide contact information by also taking advantage of the remarks attribute. As you can see here, route or route6 objects that are found in internet routing registries do not allow for you to specify TEC attribute, which is the technical contact attribute. Instead, you take advantage of the remarks attribute. Now, the last part is the PeeringDB. Now, you have to follow the following steps in order to have a PeeringDB record. You should create your account. You should validate your autonomous system number. Then you should set up your national PeeringDB record and add details to it. The last option is a company website. You can provide your contact information via your company website. You should also include the following contact details of your company, such as the Network Operations Center, support team, abuse team, and security team. I wanted to show you guys this platform known as BGP-Mon. What is it? It's called BGP Stream. It is used to see ongoing routing incidents in the world as they are happening. getting it right now. There's a platform that is used to see ongoing routing events in the global routing table. Wait. BGP stream. Yes. As you can see, let me see this routing incident in Tanzania. You can see again, show you an example for possible hijack in China. More details. You see, it is expected prefix is this, and the expected autonomous system is this, but the event detail detected advertisement, the same prefix was advertised by another autonomous system number, so this is a possible BGP hijack. So I just wanted to show you guys that. Other than that, thank you for listening to me, and that's the end of my presentation. I hope you guys are able to join the MANRS community in order to secure the global routing table on a global scale and prevent the impact and number of global routing incidents. Thank you.